All right, we will go over Note 24, the synthesis part, which in the class I kind of like only ask, this is a new type of questions. We kind of like introduce synthesis before midterm 2. And I said, okay, don't need to worry about synthesis for midterm 2 because you are only learn a certain reactions. You are not ready to do synthesis, right? So now it's a good time. Your synthesis map is ready for this. Okay, if you have your map, when you see a lot of hydroxyl group, what you do? You will go find your city of ROH and start to brainstorm how can I make alcohol, right? And then people are going to say any reaction people propose. Since we are spending some time here, let's just don't directly go to the correct answer. It's more of like answer your question on problem sets. That's the question number 6, right? So I'll also put problem sets for synthesis. It's how you think. Okay, how can we make alcohol?
Substitution.
Okay, good. Substitution. So from Rx, okay, substitute with let's say OH minus. Okay, we can do that. Yeah, and then look at this one. It's a secondary, and then we already have this one here. Looks like it's not very passable because we also adding one more carbon, right? So this is carbon number 1, carbon number 2. Okay, carbon number 1, number 2. It's not quite possible to add another one because you've now added one more carbon. Okay, if you record my notes, there's like a formation of carbon-carbon bond. Did you remember this word somewhere in my notes? Yeah, so when you see, okay, I actually have more carbon than what we have, it's kind of like narrowed down into either Grignard, well, because we went over this, but or RLI well works the same, right? We've kind of like covered this, RMGX, okay? This one is Grignard, this one is RLI, but we went over this in the same part of the notes, right? Okay. When you see, okay, I have more carbon than I do, it's you should consider this one as your primary thought, do synthesis. Okay, there are other ways of to do alcohol. Just don't write them here. But now we're pretty sure we're going to use Grignard, and then how to use Grignard in this case, we're going to cut here, right? Okay. That's what we have, okay? And then this hydroxyl group with an R, okay? We kind of like, we need here to be a hydrogen, and here it's probably going to be the Grignard, okay? Or in other way, let's just do one more step, okay? That would work, right? Okay, this will be a perfect scenario if this is not hydroxyl group. Then this can work. The problem itself is with Grignard, this negative is not, okay, instead, this carbon here, the carbon here, is partial positive. I actually do have a, okay, I actually do have a much better, okay, I do have a much better, basic hydroxyl group, the hydrogen you can treat as a free proton in alcohol because the equilibrium themselves. They have a much better hydrogen source. It's not going to attack your positive. It works the same way as long time ago when we went over RMGX cannot if you are here it's like a 1 and a 2 H3O plus. I said you have to have this step 1 and step 2. It works the same way as step 1. So if we now it's the case that your acid is in the same flask with your base, then it's going to do acid-base reaction on itself. This is the time I want this hydrogen to be disappeared. What we learned in today's class, or maybe Friday, is you can make an ether out of this. Instead of a hydrogen, you can use like ROH, okay? Or this is one way. Based on, this is route 1, okay? Based on is that primary, secondary, okay? Or RO minus, okay? It's based on which is primary, secondary, tertiary, the one that we listed before for how to synthesize ether. Based on what we have, more likely you will use the acidic one because RO minus in this way could also attack here, so it's not going to be. But if it's not this case, we're just talking about you want to generally remove the hydroxyl group, you want to put a cap on it, make it RO. Okay, if it's in general you want to do this, okay, what you can do is protect your alcohol, the hydroxyl group, into a RO group. Make sense? It's based on which specific scenario. Primary, secondary, you should consider like a case to case. It's SN1, SN2 primary because it's less hindered. In our notes, like just like a 1 step or 2 step above, that was in today's notes. There was like it's going to attack the, yeah. It's just 1 step above. It's like which side we're talking about for either less steric hindered or more steric hindered. Take that into consideration. So in the first case, in our case, we'll just choose the correct ones to protect. In this case, will be the first part because RO minus is going to attack the secondary and then do nucleophilic substitution. So in this case, it will be this one. Okay.
So when would you use RO minus for primary?
Yeah, if we don't have this, like okay, it's let me show you a specific one. Would be notes 23. Notes 23. This approaching one.
Oh yeah.
Yeah. No, just write. Okay, write notes 23 back page, approach 1. Yeah.
Okay.
Yeah. So, the case that I'm writing here is based on which hydroxyl group you are attaching to, primary, secondary, tertiary. You choose the correct cap. To most likely, this would work, but in some of the case, you will need to use RO minus. Our point is put R here. Okay, our point is put R here. Replace this hydrogen. So now my hydrogen is not going to react with my Grignard. It's not going to do acid-base reaction. Then we can use this one as that's what we learned before, right? Yeah, we can do this. Yes.
Can you do the same process, but you're splitting carbon 1 and carbon 2?
Carbon 1 and carbon 2.
Yeah, like you make your Grignard again.
Yeah.
But like like.
Oh, you split here.
Yeah. Does that also work?
That's a really good question. That's what I meant to review on notes 25, but we'll do here right after this. Okay. Let me ask, do people have question with the route? This is the route I explain in the class because I write the whole thing in the class, so I just explain why we need to protect in it. And do people good with this one? Yes.
How did we get the carbonyl on there with the double bond O?
Oh, from here to here. Okay, let me still write the whole thing so people are on the.
Could we just do reduction?
Yeah. Am I good to don't write the reduction? So from carbonyl to this one, it's just LiAlH4. Are we good?
Mm-hmm.
Are we good?
So how many steps do we have to write?
Synthesis is the tricky part. We don't tell you how many steps.
Right, but like, do you expect us to write the reduction if you didn't even write it here?
Okay, the correct answer of the synthesis will be okay. Let's write. Let me still write the whole thing. So if it's in the exam, are we clear with what the thoughts? Are we clear with how we think? Okay, I'm going to write the correct my way of writing synthesis answer. Am I good? Okay, so it's in the exam. In exam, your answer should be writing like this: HO. BR. Okay, we've explained this case is ROH, H plus, so it become RO, BR, and then it's gonna to, am I good to erase this part? Okay. E, okay. MgET2O. Just to differentiate a little bit, because I put R here, let me put R prime, if that works. So we just differentiate this a little bit. Are we good? Okay. Because I have R here. Yeah. Let me see. Okay, and then I'm running out of the space, so I'll just write the last step here. Okay. The last step is remove the R. Okay, let me